Have you ever looked at a metal object, a spoon, a wire, or a coin, and wondered where it came from? Most metals don't exist in their shiny metallic form in nature. Instead, they're hidden in the Earth's crust, combined with other elements. However, a few metals like gold and silver are so unreactive that they occur in their free, native state. The rest are found in the form of compounds, oxides, sulfides, or carbonates tucked away inside minerals. When a mineral is rich enough in metal to be used commercially, we call it an ore. Now let's compare the two forms in which metals exist. In the free state, you'll find metals like gold, silver, and platinum unreactive and pure. But reactive metals like sodium, calcium, or aluminium are never found alone. They occur in the combined state as compounds. For example, aluminium is extracted from bauxite, which is hydrated aluminium oxide. Iron comes from hematite, which is iron 3 oxide. It's important to note that not all minerals are ores, only those with high enough metal content to justify extraction. Let's talk ore types. Based on the compound formed, we have oxide ores like bauxite and hematite, sulfide ores like zinc blende and galena, and carbonate ores like calamine and malachite. There are even chloride ores, for instance, sodium chloride or rock salt. The type of ore not only tells us what metal is inside, but also how we should go about extracting it. For example, sulfide ores need roasting, while carbonate ores are usually calcined. Before we can extract the metal, we have to purify the ore. Raw ores are full of unwanted rocky material called gangue. This is where concentration comes in. It's the process of removing impurities to enrich the metal content. Depending on the ore, we might use hydraulic washing, magnetic separation, froth flotation, or even chemical leaching. Only after this step can we move on to actually freeing the metal from the compound. Not all metals are extracted the same way. The method depends heavily on the metal's reactivity. The highly reactive ones like aluminium or sodium can't be reduced using carbon, we have to use electrolysis. Moderately reactive metals like zinc and iron can be extracted by heating with carbon or aluminium. And the less reactive metals, such as mercury or copper, can sometimes be extracted just by heating their ores. So, metal reactivity and ore type determine the most economical and efficient extraction method. To wrap it all up, metals can either be found in free form or in combined states, depending on their position in the reactivity series. The journey from ore to metal involves several steps: identifying the right ore, concentrating it, and choosing the correct extraction technique. Understanding where a metal comes from and how it's obtained is the foundation of metallurgy, and it tells us just how much effort goes into creating the tools, wires, and materials we use every day.